Welcome to the today's session on hypothesis testing, one-tailed and two-tailed test. So in hypothesis testing, the distinction between one-tailed and two-tailed test relates to the directionality of the alternative hypothesis. So in one-tailed test, the alternative hypothesis specifies the direction of the effects or difference. Moreover, it focuses on whether the population parameter is significantly greater than or less than a particular value, but not both. This is very important. Moreover, the critical region is located entirely in one tail of the distribution, that is, either on the left tail or on the right tail of the distribution, and one tail tests are appropriate only when there is a clear directional predictions or when only one direction of the effect is of interest. So now let's have a look on the example. Let's say null hypothesis can be the mean IQ score of a population is 100, and the alternative hypothesis can be the mean IQ score of a population is greater than 100, and the critical region is the right tail of the distribution. Why right tail? Because it is greater than 100. So now let's consider two-tail test. So in two-tail test, the alternative hypothesis does not specify the directions of the effects or differences. So it tests whether the population parameter is significantly different from a particular value in either directions. The critical region is divided between both tail of the distributions, and two-tail tests are appropriate only when there is no specific directional predictions or when both directions of the effects are of interest. Now again, let's consider an example in two-tail. So null hypothesis can be the mean weight loss due to a diet program is 5 pounds, which is considered by a company. And the alternative hypothesis can be the mean weight loss due to a diet program is not equal to 5 pounds. That is, it can be either greater than 5 pounds or it can be less than 5 pounds. And the critical region lies on both tails of the distribution. So the choice between one tail and two tail test depends on the research questions and the specific hypothesis being tested. So it is essential to consider the context and the underlying theories when deciding which type of test to use. Additionally, the choice of one-tailed or two-tailed test affects the calculation of critical values and the p-values, which in turn influences the decision-making process in hypothesis testing. The following graph shows the left tail test, two tail test, and right tail test. In the following table, we shows the values of Z for the commonly used confidence interval. In research, normally we use 90 percentile, 95 percentage, and 99 percentage confidence interval. Now here we have the Z formula for the single population mean. Now for the better understanding of the two-tailed and one-tailed test, let's consider one example in each categories. The first example says a marketing research firm conducted a survey 10 years ago and found that the average household income of a particular geographic region is rupees 10,000. Mr. John, who has recently joined the firm as the vice president, has expressed doubt about the accuracy of the data. And for verifying the data, the firm has decided to take a random sample of 200 households that yields a sample mean for household income of rupees 11,000. Assuming that the population standard deviation of the household income is rupees 1200, verify Mr. John's doubt using the hypothesis testing. So here we have considered the alpha to be 0.05. Now let's have a look at the solution part. So in this particular example, the researcher is trying to verify whether there is any change in the average household income within 10 years. So the null hypothesis is set as no difference. That is, the average household income has not changed. So the null hypothesis can be, that is equal to H naught is equal to 10,000, and the alternative hypothesis will be HA mu is not equal to 10,000. So in the light of alternative hypothesis, we are clear that this is the case of two-tailed test. That is, the mean household income can be less than 10,000 or it can be more than 10,000, and the level of significance is 0.05. So it is a example of two-tailed test. So now let's next have a look on the next example, which says the mean lifetime of a sample of 400 fluorescent light bulbs produced by a company is found to be 1600 hours with a standard deviation of 150 hours. So test the hypothesis that the mean lifetime of the bulb produced in general is higher than the mean life of 1570 hours, considering alpha at 0.01 level of significance. Now let's have a look on the solution. In this example, the researcher is trying to verify whether mean life of the bulb is higher than 1570 hours. So the null hypothesis is set as no change. That is, the mean life of the bulb has not changed. That is, H naught mu is equal to 1570. And the alternative hypothesis can be H naught HA mu is greater than 1570. So considering the alternative hypothesis, we are clear that this is a case of one-tailed test. That is, the mean life of the bulb is greater than 1570 hours, and at the level of significance is 0.01. So I hope in this video you will be able to get a better understanding of one-tailed and two-tailed test. Thanks for listening to this video. Thank you.